Welcome back everyone. Today we learn about nitrogen and ammonia. Nitrogen is relatively unreactive because of strong triple covalent bonds between the N atoms. Nitrogen forms ionic compounds, magnesium nitride and sodium nitride. It also forms covalent compounds, ammonia and nitrogen. Nitrogen is essential for life, as it is used in the making of protein, and is also used for making fertilizers. Nitrogen provides an inert atmosphere for making products that are easily oxidized and is also used in the packing of food. As a test for nitrogen, we can burn magnesium and nitrogen to form magnesium nitride, and magnesium nitride dissolves in water to release ammonia. How do we produce ammonia? In a lab setting, we can add an alkali to an ammonium salt, and under gentle warming, ammonia will be produced. The diagram below illustrates the Haber process, and the Haber process results in the production of ammonia gas as seen in the equation below. In the Haber process, condensation is used as a separation technique for the mixture, and since ammonia has the highest boiling point, it is the first to be condensed. A catalyst is involved as well, as it helps to speed up the reaction, and it is not used up. It tends to be a transition metal, and fine powder is more effective than lumps as there is a larger exposed area for reaction. For this process, the catalyst tends to be iron, and temperature is at 450 degrees Celsius, with a pressure of approximately 200 atm. These are two equations that show different ways ammonia can be produced in chemical reactions. How should ammonia be collected? Since ammonia has a low density, it is collected by upward delivery or downward displacement of air. It is not collected through displacement of water, as it is very soluble in water. It can also be collected in the heating of ammonium salt, warming of alkali in ammonium salt, or warming of alkali with zinc or aluminium and nitrate. One use of ammonia is that it can be used to manufacture nitric acid. Ammonia reacts with oxygen to produce nitrogen monoxide and steam, and in the subsequent chemical reactions as follows, the final step will result in nitric acid being produced. Not only that, ammonia can also be used to make nitrogen fertilizers, which include ammonium sulfate and ammonium nitrate. Here are the chemical reactions that show how ammonium sulfate and ammonium nitrate respectively can be formed. Fertilizer. Plants require pKn. P stands for phosphorus, and it is needed in order for the growth of healthy roots. K stands for potassium, and it is needed for photosynthesis. N stands for nitrogen, and it is used to make protein and for the plant's growth. pKn is obtained from fertilizers and are absorbed through roots, and solution form in these fertilizers all contain pKnN. Phosphorus is present in phosphate and hydrogen phosphate. Phosphate is also generally insoluble except for group 1 phosphates, so hydrogen phosphate is being used instead. Here is a list of some fertilizers that are being utilized. CHNO are not supplied in the fertilizers, however CNO can be obtained through carbon dioxide. And HNO is obtained through water. Plants grow best in soil that has pH value of around 7, and thus neutral soil is most desired. However, due to acid rain, the pH value of soil tends to be lower than 7. A commonly asked question is that is calcium carbonate or calcium hydroxide better at neutralizing acidic soil? The two equations below show how calcium carbonate and calcium hydroxide would react with the acid that comes from acid rain. The disadvantages of calcium hydroxide is that it reacts with ammonium salt fertilizers to give ammonia, which would result in loss of nitrogen required by plants. Not only that, it is also partially soluble in water, and thus can be washed away by rain. It also forms an alkaline solution that causes pH of soil to increase. On the other hand, calcium carbonate is much more advantageous. Calcium carbonate does not react with ammonium salt fertilizer and thus can be added together with fertilizers. It is also insoluble and thus not likely to be washed away, and finally, unlike calcium hydroxide, it does not make the soil alkaline when added in excess. Water pollution. Eutrophication is often a product of water pollution, and it occurs when nitrates or phosphates are reacted with stagnant water. The nitrates can come from fertilizers that are carried by rainwater. The phosphates come from detergent that is delivered by household water. Eutrophication results in water having a foul smell, and it causes the water body to be incapable of supporting aquatic life due to it using up oxygen supply rapidly and reducing the ability to produce oxygen supply in water. It promotes the growth of algae, which reduces the presence of sunlight in water. It also reduces the rate of photosynthesis, causing oxygen supply to be low. Lastly, it encourages the growth of anaerobic bacteria, which decomposes organic matter, and hence gives water a foul smell. Lastly, nitrates. Nitrates are dangerous to humans, and especially babies, as it prevents hemoglobin in the blood from transporting oxygen around the body properly, and may also be responsible for the formation of nitrosoamines. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye bye.